We're going to look at some sets of data and we're going to determine whether they are linear, quadratic, or exponential. We've already done all three of these, okay? So let's talk about what the graphs look like so that we can graph them and tell if which model that they actually fit. So linear, that means a line. So it's the graph, actually I'm not going to put the axes on here. Looks like this, right? Or maybe it goes down. One of those two. Yes? If you don't know, you need to speak up.
Wait, what's the question?
Otherwise, don't complain when you don't understand.
What's the question?
That's what a linear graph looks like. Do you understand that that's what a linear graph looks like? The graph of a line. What does a quadratic graph look like? This is what we just did. A U or a parabola, right? It has a vertex. It looks like this, yes, or like this. The other kind of graph we talked about was exponential. When we talked about growth and decay, that's been a little while back. What does growth and decay look like? That's right. It kind of eases up and then shoots up real fast. Or it comes down real fast. This is growth, that's decay. And then it kind of evens out. Right? So what we're going to do is we're going to take a set of points and we're going to decide if that set of points is linear, quadratic, or exponential. So to do that, we're going to start out by graphing them. We might look at how to analyze them tomorrow, but we'll see. But right now, we're just going to look at them and say what they look like when we graph them, okay? Okay, Miss Mickey. Okay, class. That's not me. Okay, so I'm going to give you a set of points. I want you to graph them. Tell me what they look like. Tell me if they look like linear, exponential, or quadratic.
No, your screen is bright as I don't know what.
All right, I'm going to pause. If you are still graphing, you can continue. I'm going to go ahead and graph these. Oh, no, I need to move mine.
Why you got a lot of that?
All right. I'm going to plot each point. All right, starting with -4, 1 over 32. Now, if you put 1 over 32 on your calculator, what do you get? 0.03. So it's really, really little, right?
0.03.
So 1, 2, 3, 4, -4, and it's going to be super duper close to 0. How about 1/8? What do you get? 0.125. So I moved up a little bit, but not much, right? So -2 up just a little bit. 0, 1/2. 1/2 is easy, right? 0, 1/2. 2, 2. 2, 1, 2. And then 3, 4, 1, 2, 3, 4, 5, 6, 7, and 8. If I connected these,
Okay, but you didn't put that. Okay.
what is it?
I thought you didn't put on the right spot.
What does that look like? Exponential.
So we gotta put in.
Yeah.
So that's like, is that kind of what we're going to do?
You're going to have sets of points you're going to graph, and you're going to tell whether it's linear, exponential, or quadratic.
What you mean?
Yeah, those are easy questions. Quadratic.
So I'm looking for graphs on each one of yours. Now tomorrow we'll probably start talking about writing some equations of these. All right, let's look at the next one. You okay?
If I ever lose my soul, I'm gonna cry. I mean, if I ever lose my
Oh
voice.
my goodness. Let me put your points up here.
If I ever lose my voice, I'm gonna cry for things like that. I can sit there and not talk.
Some more.
I'm just saying, I'm already going to write on paper. Be like,
Graph these and tell me what you think it is. If it's exponential, if it's quadratic, or if it's linear. 3, 4, 5. I'll give you just a second to graph them and then 1. Negative 4, 1, 2, 3, 4, 1.
line
Negative 2, 1, 2, 0, 3.
You said line
2, 4. Most of you got this. You already said that it was linear. If I connect those, yes, it is a linear function. Yeah.
If all the y's are like that, how they like 1, 2, 3, 4, 5, is it always going to be linear?
No, depending on what, if the x's are increasing at the same interval, then yes. See how the x's are going up by 2 each time? And if the bottoms are going up by the same, yes. But you'd have to look at that to make sure, because if it was negative 4, 1, but then it was 0, 2, and then it was 8, 3, then no, not necessarily. It's just because the x's are increasing at the same interval too, is why. All right, one more. Maybe not.
Did that thing say
Christian?
939?
Yes, 59. All right, one more. Negative 4, 5. Negative 2, 2. 0, 1. 2, 2. And 4, 5. Graph them, see what happens. I think most of you have finished graphing, or I assume you have since you're talking about other stuff now. Negative 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, and 5. Negative 2, 2. 0, 1. 2, 2. And 4, 5. Pretty easy to tell what this one is, right? If I connect these, yeah.
Alright, so when we have like quadratic equations,
Yeah.
and we're plugging in
Shh, guys! Zaya.
Oh,
I'll put it on the board. Put that up. No phone. Ask me again, Ricky.
you know how you can do these equations and calculate?
Uh-huh.
You do negative.
Like putting the points in and plotting them now.
y'all folks need to use it.
All right.